Okay, for people joining this live stream, we are reviewing pieces of experimental functionality in Wolfram Language and trying to figure out what it will take to make them not experimental anymore. So first up for this morning, the compiler. So these things are not experimental, but their functionality is still far from what it will ultimately be. I mean, so what is there to discuss here? I mean, these are, or they are currently tagged as experimental.
They are currently tagged. I mean, I'd be quite happy for that to change.
I'm not. I just don't think that they're robust enough. I mean, I think that you can't expect a function in the wild to compile. That's really the criterion.
I mean, well, the function in the what? Okay, fine, whatever. Then let's not bother. That's fine.
Why do you think that they should be de-experimentalized?
Well, because I think they're quite robust and they produce good code.
Well, I understand that.
I mean, in that sense, they're far from experimental. They're quite mature.
Well, so compiled code function, I consider to be not that experimental, right?
Yeah.
But Tom, people are not going to think these are, they're not finished.
Well, fine. Then let's not spend time discussing it. That's fine with me.
Does Itai have an opinion about this?
I don't have a super strong opinion. I mean, I think in terms of sort of, is the design of these functions likely to change?
No, it's
probably not. But I agree.
The functionality is far from what it will be.
Right.
So the question is, does that, I mean, often our criterion for de-experimentalizing is that the design is fixed.
You could say that about ndsolve in version 1.2, that it's all version 2. It does unbelievably more now than it did then, but fine.
I'm thinking about it. I'm thinking about it. I mean, look, I don't want people to think that their compiled code functions are going to stop working, because they're not.
Yeah.
On the other hand, I don't want people to try function compile and say, this doesn't compile my code, I'm not interested, and then go away for 10 years and not try it again. See what I'm saying?
Sure.
I guess one possible benchmark is, how far do we think we are from compiling sort of down value based functions?
Well, but Itai, some of the function compile takes a function, so it's kind of irrelevant for that.
Right, which means it's not. Do we know the design for when we're going to do down value compilation? What will that design look like?
I'm unclear on that. It will probably get collections of symbols.
Yeah. I would imagine. Well, it's probably symbol compile or some such other thing.
Something like that, maybe, yes.
Well, I mean, why can't function compile take a symbol and assume that it's compiling the down values of that symbol?
Well, first of all, because function compile is not hold all.
But if you just give it the symbol, right? I mean.
Oh, I see what you're saying. Yeah.
I mean, if we're going to start compiling own values, that's maybe something else. But
that's kind of stupid.
Yeah, exactly.
Fair point. Yeah, I mean, that would not be inconsistent. The one question, though, yeah. The problem is this returns a compiled code function, right? What does it return, or what does it do in the down value case?
Well, it could return something like an association if there's multiple functions.
No, but I understand, but that's not very useful. What you actually want it to do is to replace the definition of f when it can with a compiled definition.
Well, then that's a different that's not function compile.
I understand that, but I don't think it's particularly useful. I mean, what's it going to do? It's going to, I mean, look,
I think that
one way to do it, one way to do this is the following. Okay. Okay, so I have an idea. Okay, so what we could do is function compile of f could give you something which is called compiled function. What is compiled function? What is compiled function? What is that?
Well, that's the legacy compiler. So,
okay, well,
I mean, it could make one function that overloads all the different versions into one thing and has the dispatching code. That would be possible.
I understand that. So what I'm suggesting is a headdress approach. Well, let's just imagine this is called compiled symbol, just for the sake of having something different, right? So then the function compile would return compiled symbol, and then what you would do is, instead of calling f of 7, which would give you your actual original definition, you'd say compiled symbol f of 7, and that would give you the compiled version.
Sure, something that's possible. But you know, it could equally well have function compile of f return a compiled code function, and then the compiled code function applied to 7 would give you.
No, that won't work, because what about pattern matching?
Well, the pattern matching is going to be sort of factored into it.
But what does it actually return? In other words, if you say, return
a function that will implement the patterns as you dispatch. It'll dispatch over the patterns.
No, but you're not answering my question. What does it do? I mean, the whole point is, are you suggesting that we overwrite the definition of f?
I mean, I think that's one possible mode, but there's a core thing underneath of that returns a function.
Really?
Well,
so what does it do if the pattern match fails? What does the function return?
Well, then it does, it can call in the function dispatch, it can dispatch over the patterns.
Look, Tom, either if you've got a definition, okay, wait a second. If you've got some down values, okay, they only match certain patterns.
Right.
Right? Okay, so this is a long sort of missing link, is a pure function that rejects certain arguments. We've never had that.
Well, we've never had pattern matching built into pure functions. That's what we're talking about.
Yes, we've had a design for 25 years for how to do that.
So
wait. Are we planning to execute that? Because that's a big deal, which will affect a lot of other parts of the system.
Well, the compiled part of it would do that.
No, but we can't do that. We're not going to do that. We're not going to have some special proboscis for compiled functions. That's
not a special
for everything else. What's
that?
The
whole thing is a proboscis.
No.
There's an optimized way of implementing it in cases, and there's a fallback.
No. Look. I mean, we could perfectly well have, if we wanted to, just like we have, function x, y, x plus y, right? We could imagine a syntax where this thing here
is E. It's like E. You'd write this function of E, and then you would have rules like that match against E, for example.
Well, I mean, what I'm thinking of is we can do things like this, where this could perfectly well have a destructuring thing.
Well, you might want to connect the patterns with the bodies. So
but that does that. That does that because the names of the pattern variables become the objects in the body. Okay.
Wait. You might have different bodies.
No, I'm talking about.
Yeah, but you're going to have multiple patterns. That's the benefit.
I see. So what you're suggesting is that there can be a function which is an association effectively that has various pattern forms here.
Yeah, arrow, yeah.
whatever
Yeah,
it is.
yeah,
Right.
yeah,
Okay.
yeah.
So in a sense, what that's doing is it's taking the down values list.
Yeah. Yeah, I mean, this is the obvious thing. There are some differences in scoping that would need to be, thought through. But the way that pattern variables and down value scope is unfortunately different from the way that function variables scope. But whatever.
No, but there's a different issue here, which is what does it do if none of the patterns match? So what you've done is you've got this function object and you're applying to things.
Well, I mean, it could have a default. I mean, there's a bunch of things we could do. We could have, require a catch-all case. So it's not valid input if there isn't. For example, we could do that.
Well, that would then be a very different kind of thing. But yes. Okay, look, this is not properly designed. We should not de-experimentalize the pure function case until we've designed this, because it may affect the pure function case.
Then I don't think we should de-experimentalize any of the functions.
Fine.
Because they all fit together.
Okay. I mean, I think that I'm hoping that before too long we will be able to, but I think that two things have to be true. We have to understand the down value case. And by the way, Tom, I mean, it's been a year since we started talking about the down value case.
No, it's longer than that. We talked about that on day one. You might have.
I understand that, but with specificity. And then what we need to do here, we need to get a design for this down value case.
Sure.
So let's make sure in the next few weeks that we talk about this, so that we make sure we know.
Yeah, we can talk about this, but we mustn't have a premature design that then we find is a waste of time.
Well, I hope it's not premature, because I thought that was the thing that was going to be actively worked on real soon.
Yes, fine. When it's actively worked on. Well, remember there's 12.1 that's out there, and data structure and things.
Yeah, I know.
Yeah, but no, okay. This is totally, this is the next thing after 12.1 and data structure. Absolutely.
All right. Okay. We have a question on the live stream from Mohammed asking, what's the difference between library link and WSTP, which is something that actually relates to our next topic of numeric array. Well, I'm not sure what it exactly relates to here. Okay, so WSTP is a transport protocol, as its name suggests. It is what has been called MathLink forever. It was invented in 1989. It is the symbolic transport protocol that allows one that all of the link functions that, like link open, that it's the way the front end communicates with the kernel, it's way that a kernel communicates with subkernels in parallel computing. WSTP supports all the various operations that are needed to have rich communication, like what does it do if a dialogue is started? What does it do if messages are passed? Library link, on the other hand, is for calling binary programs with low-level data structures. I don't know. I mean, maybe there's a little bit more to say about this, because I mean, after all, WSTP does have a representation, and we have the wrong people here to discuss the details of this. Perhaps does have a representation of many kinds of. I mean, WSTP has the concept of is about sending symbolic expressions back and forth. Library link, well, describe what it does.
Well, I think you're focusing on the wrong aspect, because they can both send symbolic expressions and efficiently transport, low-level structures like packed arrays.
WSTP is inter-process communication. Library link is for dynamic library communication.
Basically. So
there's a dynamic library with library link.
But why is it the case that library link does not support all the WSTP syntax? Because you could want to
It does. You can use a link object in library link. One of the things you can have is to use WSTP.
So in other words, you can use the C library bindings on the
to communicate with the kernel, correct?
Okay. But so what's
and in fact, oftentimes libraries will use, if they need to, reserialize or something, they'll use a loopback link inside of their library link library to do that sort of thing.
Okay, so to what extent is the document? Where is the documentation of library link? Is this it?
Well, right, that's an overview that links to many things.
Okay.
And there's undoubtedly a guide page linked to somewhere.
This looks like it's bad formatting. What is this? That looks like bad formatting at the very least.
Right. There's probably a link to a guide page up at the top, actually. Related guides. There you go.
Why is that grayed out? So is anybody is Devon here? Let's see who is DMing. Okay, so that's one bug is that's grayed out. The second bug is those headings are wrong. Okay. Okay. So can somebody talk through what's on here?
Right.
Is
so
Wolfram
there
Language.
are functions there, get WSTP and process WSTP. So basic in terms of sort of the C bindings, library link is a superset of WSTP. The main difference is that library link is really for an in-process, right? You load a library into the kernel process as opposed to connecting to some other binary.
This is really a pretty sad list here. Look at all these different conventions and random junk that's in here. Oh boy. Okay. Okay. So what is our objective here?
So Raj put these pages here because he felt like he had to put the pages here, but I think this is an irrelevant question because all of these, if you look, all of those functions are numeric arrays. So if the underlying numeric array is experimental, then I think the library link function.
But I don't even see where the numeric array, this numeric array clone is not listed here. Why not?
I don't know. I am surprised by that. Maybe because I don't know if that's just an oversight or if because they were experimental, we decided not to link them. I don't remember.
Okay, so who is in charge of this page and who's in charge of getting those? Who's in charge of library link right now? What's that?
Library link in general, I think Tom maybe?
No, Tom is not working on this. Tom is working only on the compiler.
Right, so maybe then Rob, but we have been adding all of these documentation. I guess we can be in charge of adding all the numeric array functions if we think adding experimental functions to the guide page is fine.
Yes, because
they
say
are,
they're experimental.
However, linked from the tutorial. If you go back to that,
I don't care. They're not on the guide page, and they should be. Yep. Okay, and there also should be probably a separate guide page for these C language functions that groups them in a nice way and so on, because there are a bunch more of these functions.
I agree that, yeah, I was going to suggest some subsectioning there would definitely be nice.
And this is complicated and, okay, somebody has to be in charge of all of this functionality. Who is it? Is Todd Gailey part of this story or what?
No. So I would say from a code perspective, Rob is in charge, but Shadi's group, as the heaviest consumers, has been largely in charge of the documentation.
Can I say something? Library link is probably going to become obsolete as well. I mean, compiled code function does all of this and better.
If you could see me, you would see me rolling my eyes.
Well, right. I'm telling you, I have no doubt you're rolling your eyes.
Okay, would you like to explain?
What about me, Tom? Am I also rolling my eyes?
I have no idea. You roll them quite a lot.
Okay, explain the statement, Tom.
I'm just saying that the interfacing to code loaded into the kernel, that's exactly what compiled code function's doing.
Okay, but
there's a lot
functionality of okay. So on the client on the side of the okay. So what we've got, you can make since 1989 an installable program using a template file or using raw WSTP commands in the C code. Yes?
Correct.
Correct.
Okay. If you've got an installable program, is it the case that you can use library link to load that installable program into the memory space of your running?
No, that's not correct. That's completely incorrect.
Why not?
Because the installable program is an executable, and library link works with libraries, not with executables.
Right. If your program was architected such that the main executable only loaded a single library and then ran that library, then it is conceivable that you could change.
You could build your thing in two ways conveniently.
Right. But I mean, a program, if it's in the program, it has its own main, it has all the extra stuff of being an actual executable program, and you can't just load a second main into your into your own process space.
Wait a minute. Doesn't when you use WSTP, doesn't it create a separate main for you? I seem to remember that template files, which I made up back in.
Well, sure, but that goes in the external right? WSTP launches an external executable and then communicates with it.
Yes.
There's a thing called mprep, which helps you do that from some non-WL specification.
Right. But that's a thing that is invoked by the C compiler. Isn't that correct?
Well, the C compiler will make whatever you want. It can make a library or an executable.
No.
Mprep is invoked by you, or probably in most cases by your make file.
Right, to make a .mc file that comes from the template file, correct?
Right, either a .c or a .cxx, depending on which language you're using. Right, and that converts the .tm into either a .c or a .cxx, and then you apply your favorite compiler to that.
Right, okay, right, I remember. So that mechanism is 30 years old. So explain library link relative to that mechanism.
So that is a completely different, right? It's an intra-process. It's a different mechanism. You have your .c, which will include Wolfram library.h, I think is the main header, and possibly some subheaders. And you compile that, and you do not create an executable. You create
just a .o file.
No, a .so or DLL or dilib.
Okay, fine. But so what do the entry points in that look like?
The library exports functions, and you call those functions from the kernel. So if you look at that first example, demo is the name of a library, and demo II is the name of a function in that library.
Okay, so kind of on the cell surface, so to speak, of the DLL is a demo II tag.
Correct. Yes, correct. A function. Yes. Good.
Right. Whereas in the case of WSTP, the only exposed surface is main argc argv. Is that correct?
Well, really, I mean, from the kernel's point of view, the only thing that's really exposed is the link object, right?
Correct.
So you call it and you give it command. Yeah, I guess argv argc is relevant.
No, but actually that's not correct, because in a template file you can specify multiple functions. So there is obviously a protocol that calls into the main program and says which function you are trying to call.
Yeah, there's one main function that gets created, and that dispatches to individual functions based upon what's coming down.
As opposed to the library link case where each individual piece of executable code has a separately exposed tag that says that it is callable from the outside world.
Yeah, that's good.
Right, and in particular, right, the way the kernel calls it, right, it calls the right. So one of the things mprep does is embed argv handling for managing links. So the kernel will call the external program with appropriate options so that to open a link, and then all the communication basically happens over that link. As opposed to in library link, you directly load this function and bind it to this library function, and then you call library function, which will dispatch into the .so or .dylib.
Okay.
You create it.
So one question is, okay, the bad documentation of library link, that's one issue. Second issue is consistency between three things now. We've got WSTP, we've got library link, and we've got apparently the compiler.
Right.
How does the compiler relate to? So didn't Christopher have some project?
He did, yes, and he'd find it immensely easier now. I mean, now it would be.
What was his project again? To implement external function for C using this mechanism. Is that correct?
Using the compiler, it would work very well.
Can you describe the project, please?
Well, what Christopher was trying to do was he was having a library, and he was building an interface to that library and putting a compiled code function around it.
As a way to call that library.
As a way to call that library, but doing it sort of automatically based upon introspecting header files.
Okay, so wait a minute. It was taking C source code with its header files and analyzing those header files to generate a type declaration that could then be used automatically by something in library link?
No, it would be
directly
in the
compiler.
It was generating a function that was then compiled, and a compiled code function.
So how do things like memory management work for that?
Well, no different from any of these. So, no different. If you want to connect things through into expressions, then that's what data structure does.
Wait a second.
So he's just calling functions.
Yeah, but let's imagine that we're calling an external C program with some giant tensor who allocates the memory for that tensor?
Right, then the external program would allocate, and when you finished with it, you would have to remember to call deallocate tensor.
Why? When the thing exits, it's finished. I don't understand.
No.
When the process exits,
you're confusing two things. Both of them allocate it, right? The kernel allocates it because it creates this expression, and then when you send it over mathlink, then as it's receiving this tensor over the link, the external program will,
But is that true for library link as well? That it doesn't have shared memory? I thought it had shared memory.
It does.
Okay, so what's the relationship between numeric array? Isn't it the case that you can have a numeric array that appears to be in standard Wolfram language memory space, but yet is acted upon by C code in a library?
That's correct. Without copying, that's correct.
Okay, so explain then, in Christopher's project or in the compiler, what is the analogous thing? So WSTP, it has to copy.
There's a disown. Look, you see, in fact, if you look on the left-hand side,
I can see there's a disown. I'm disappointed by the fact that there has to be a disown.
Right.
Okay, so I'm asking, why does there have to be a disown? Why is it not that the memory is managed? In other words,
because C is not a garbage collected language. So you have to have some way for the C code to tell the kernel that it's finished with something. Otherwise, that numeric array might get collected.
So Christopher did not have a solution to that. Christopher's system, even though it could automatically read the header files and figure out the types of all the variables and things, it did not have a mechanism for automatically disowning things? Or did it?
I think it must have done, otherwise it'll have been leaking memory.
I think Stephen, I think the basic answer to your question is void star, right? I mean, in C, you can pass around memory. There's no notion of whether the memory is owned or not. So if you're executing arbitrary C code, you have to have some responsibility for declaring, okay, I'm actually done with this memory.
I understand that, but if the memory is shared, well, I get it. I get it. I mean, I get it. That it could be the case that you will recall that C program and you want the C program to still have that thing in memory.
Yeah, absolutely. Yeah, absolutely. That's why.
Even though the thing was removed on the Wolfram Language side, even though the Wolfram Language thing said we don't have any more pointers to this, we don't have any more links to this, you can get rid of it.
Yeah. That's exactly correct.
So it can be freeable on the Wolfram Language side, but not freeable on the C side.
Right. And having an active disown, it prevents it from being collected in the kernel.
All right, so let's walk through again the role of library link. So, I mean, we think the documentation is not up to snuff, but to what extent is the code base of library link being, I mean, we're not rewriting that code base. We're simply providing an interface to it through the compiler. Is that a true statement?
You mean actively at the moment? No, we're not doing that.
Well, we're not going to get to it anytime in the next 5 years. So basically that we're not.
Right. Can I just point out, people add new types to library link every 6 months, and it takes them months of work to add one type.
Okay, I don't really care. I mean, the question that I'm asking is, what is the plan? What's the overall plan with respect to the compiler and library link and WSTP? What is the goal design-wise?
I mean,
WSTP
is fundamentally different.
All right, let's put that on the side. Okay, library link versus the compiler. Okay,
well, I would never use library link. I would always use the compiler.
Okay. Much better. Okay, is every piece of functionality in library link now available in the compiler?
The names of the functions aren't, but I think you can do very equivalent things and better.
Well, so why don't we make a binding where we have the names of those functions?
Yeah, we
okay, so let me understand what would then be possible. So what would be the analog? We've got library function load. What is the analog of that in the compiler?
Well, the compiler works with functions. So to do library function load, you would, it would need some amount of work, but you would create a function that took the expression interface and, denatured it according to length and type. But it would be immensely faster.
Okay, hold on. I want to know with specificity, okay? Okay, right now, people have C code that has library link functions in it, right?
Right.
Okay, and that C code is then taken, it is created as a DLL. They use the C compiler to make a DLL. Then they use library function load to load that DLL into our address space. And that exposes an interface to the function, which is then called, and something has to know what food is fed to that function, right? What stores the information on what kind of diet the function has, what structure of data structures get sent to it, and so on.
So there's code in the kernel that does that. There's code in the C functions that does that as well. But this code in the C functions is quite awkward.
Okay, hold on. I'm asking a different question. In the case of, what used to be MathLink, which I remember because I designed it in 1989, the way that works is it exposes an installable program, exposes essentially patterns that determine what its diet is, what can be fed to it, right? Okay, what is the analog of that for a library link DLL? What is the analog of that for a function in a library link DLL?
So basically, the C signature of the function determines what it can consume.
Okay, so it's a raw C signature.
Well, hang on. That's not the signature of the functions is all the same. The functions don't have different signatures.
Okay, then what determines?
They take these argument things, Itai. You could look at some of the examples, Stephen, if you want to know.
Okay, well, let me see an example then. Where is it?
We'll go into the user guide. And, you know, and there's like a look at, say, there's probably a simple example.
No, we're pretty quickly in memory management.
Well, that's more complicated.
No. Up above, function arguments and results.
Right. So there, look, demo II. All these functions have the same signature.
What is mint I0?
That's a machine integer.
Okay, but so that's our data type.
That's our data type, correct.
Where do we have a documentation of our data types?
I'm not sure.
Okay, that's kind of
probably that link called type specification.
Yeah.
Where?
In the middle, slightly below where your cursor. Yeah.
Yeah, that. Yeah, there we go.
That's a design mess. But anyway. Okay. Okay.
But you see, that function, Stephen, it's written with this mint argc, m argument, args, m argument res. So this isn't a raw C function. This is a C function that has to be written in a special way.
What is m argument?
It's a union. It describes in this thing. It's a union of all the. Well, it's described right underneath.
But could it be an arbitrary struct or not?
No. It's a union of one of those types. It has to be one of those.
M argument get integer is like the WSTP get integer thing. Is that correct?
Well, in what sense like? It's
well, in the sense that if you have a manual, in the case of a template file from 30 years ago, right? There's the idea of sending, there's certain types which can be specified in the template file. If you want a more complicated data structure, you have to manually get that data structure off the link.
Right. There's no simple way to get things off the link.
I don't understand. What are you talking about?
And the get integer will return an integer, even if there isn't an integer being written out.
I understand that, but this is the analog of this args thing. Appears to be just a, this is what a mess. I mean, this is just a raw piece of memory that just happens to have those types in it, but no struct.
It's basically a cast. It's saying read this argument as an integer, as a machine.
Yeah, that's it. Yeah.
I get it. And those things are just a blob of memory that happens to be able to store any of those native types, basically.
Yeah.
But mtensor could be an arbitrary sized object, so I'm very confused by this.
No, it's a pointer. It's not arbitrary sized, it's an address.
But they're all pointers here.
No, they're not.
Well, mint says star integer, so it's a pointer too.
That's just to give them a uniform packing size.
Right.
Are they pointers?
All the union types have the same size, right? Everything in the union has the same size. So everything that's literally in the union is the same size because it's a pointer to the actual data. Right, and I'm sure that the definition of m argument get integer is something like
reference the thing, yeah.
Mint of star m argument or something like that.
Okay, once again I ask, okay, so let's take a look here at the analogous thing. Okay, so let's look at what I wanted to type. I want to look at the
C language functions, probably. At the top.
No, this thing. Okay. So this is the old 30-year-old template file mechanism, right? It's pretty clean, actually.
Well, it's not. Why isn't it Wolfram Language? Why is it a wacky alternative language?
These days, it would be a Wolfram Language.
Right.
Thing.
That's
okay.
I mean, it could be written in top level now quite easily.
Yes, it could be.
Yeah,
could easily be. But it's nice, and this is nice and easy to read here, and now it will be an association. But the point here is this is a declaration. I mean, it's really very simple what you give here. In the actual, this is the native name in the C code of that function, right? I'm making sense? And this is simply saying what will be put on the stack to be passed to that function. Am I making sense?
Sure, but again, the whole point is that this is all carefully managed, right? Well,
it's not true. No, there's a manual case here where you are explicitly feeding things over, I don't know whether it's covered here, but where you're explicitly feeding things over, let's take a look here. Okay, that's evaluation.
Sure. I mean, you don't have to use template files. You can.
Yeah.
But
but even in template files, you can have a manual mode in which you are explicitly picking and getting, putting and getting structures from the link, right? Which is, I think, presumably analogous to numeric array get data.
No.
No.
Why not?
Because numeric array gets the raw data in the numeric array.
That's what this does. When you get the thing from the link, you say, WSTP get integer, for example, it gets the integer.
Right, and it returns a Mathematica integer.
No, it doesn't. It returns a C code integer. Returns a C integer that you put into...
There's nothing in WSTP that returns an address of data that was written.
That's not true. It's not true. There's a bunch of things that do. That's how you deal with any data structure that isn't explicitly there. Anything you couldn't pass on the stack and see, you give a pointer to, and it works the same way.
No, you iterate over it. It tells you the number of arguments. It tells you what the head is, things like that.
That's one way of doing it. I think okay, fair enough. Fair enough. Oh boy, guys, we have.
I mean, there's slightly different things. You see, WSTP is serializing, deserializing, and serializing. It's a serialization interface. Okay. This is an API interface. They're not quite the same thing.
So the bottom line is, we've got several things running around here, and they need proper design. We've got the external function mechanism that Christopher started building, which I think had a pretty good design idea.
Yeah, I think that's an interesting way to go. It would go a lot further now.
Well, maybe we should, I mean, Todd and his merry band are the people who would be building that.
That would be great.
So maybe we can maybe we can look at that again. But the way that would work to a user is you've got a lump of C code, and you would declare something that says which functions you are trying to expose, correct?
Yeah, I think that's feasible.
No, let's walk through it in more detail, right?
You might just have a header file and a library.
Right, but the end result is that you will have an external function that, just like right now, you might have an external function that refers to the Python interpreter, for example, right? Like for example, I could say here, if I'm not mistaken, something like, maybe somebody can help me with this. External function, I don't know the name of any Python function.
There's probably some examples.
What's the name of a Python function? Give me a Python function.
Print.
No, something that does an operation on data. Like a string to ASCII or something. Well, here we go.
What about ABS?
I've got that here. Yes, okay. Here we go. All right. So then, Okay, so then this is the external function, right? And that external function now is, will do its thing, right? And this will blow up probably. Oh, it worked. Amazing. Oh, it probably passed it correctly as a, okay, in any case. So what this is doing is, it has a running Python session, and it's sending those functions. So the idea was that if you have a C binary that has more specialized functions that it supports, this is the generic Python interpreter, but the idea would be that it looks like external function of C executable and then some entry point.
But there's a big difference here. External function here knows that it's going to Python, so it knows how to serialize and deserialize between Wolfram Language and Python in some unwashed C.
I know. So you have got to get something here, which is a DLL, or it is some external program that could be a separate process, but it has to have had its interface defined, right? So, this could be a myprogram.exe here, and then it could be which has been created by something that knows how to deal with an abs here, right? That's just like the installable program mechanism, right? That's like calling an external program. Am I making sense?
Not to me.
Okay, let's go through this again. All right, so in the case of install, right, what you do is given install, so that install actually will expose these functions.
Yeah, and install bootstraps itself.
Yes, but there is a low-level function called, what is it called? What is the function that actually sends something to install? Do you understand what I'm talking about? There's a thing, I can't remember what it's called now. That
when you invoke install, it launches the program and it does some bootstrapping thing that sets up function definitions.
Yes, I know that. If you look at the result of an install, you will see the thing that it does. If you actually look at that definition. Okay?
Yeah. If you look at the C code that's generated, you can see that.
It's not the C code. If I say here, what the heck? Is this not working anymore? Why does it not show me that? Missing unknown symbol. I'm totally confused here. This documentation needed to be rerun, but what I'm looking for, I think it's called external call or something. It's the thing that's actually in that is actually in the down values.
There's a thing called external call, yeah.
What
you
is
spelled
going
down values wrong.
I don't understand that. I don't understand where it went. Maybe it's protected or something. But in any case, the okay. Okay, we've had a bunch of comments on our live stream here. Comments about graphics being real measurement aware, that we had a long discussion about, what was it, last week? It's much more complicated than you can possibly imagine, sadly, because we don't know how big the screen is. Complaints about WSTP and links, issues of connecting remote kernels to a front end. I don't know exactly what
we have improvements on that front for 12.1.
That's good. There's still more streamlining to be done there. complaints about poor documentation for LibraryLink and so on. Main program have an entry point that takes the name of a module. Yeah, I agree. Right. Okay, so look, we've got several things going on here. I think let's have a separate discussion about this mess of how we actually, whether we can use, and all these things which say, oh, we just need to do a little bit of work. That's not good enough. We've got to actually provide something.
Don't forget, the alternatives are huge amounts of work in some other way.
No.
Yes.
No, we got a bunch of stuff that already works, although it's very badly documented.
People are adding more things. They're extending it. They do that all the time.
I don't care. The fact is that, look, what we've got to do is clean up. We've got to have a clean, uniform way to do this, whether it is using quotes LibraryLink or whether it's using quotes the compiler or whether it's using some combination of these, I don't know. If somebody thinks they already have an idea how to do this, that would be great. Does anybody think they have that idea?
Well, I've said yes, but you can discount that if you don't believe
it. But your yes is throw away LibraryLink, use the compiler, but it hasn't been built yet.
I didn't say that, Stephen. I didn't say that.
Okay. What is your roadmap for what to do?
Well, I think new data types that people want to add, shouldn't be added to LibraryLink.
No, I'm asking you, what are we doing with LibraryLink? What are we doing with the compiler?
Well,
just saying that you can add a new data type in the compiler is irrelevant. We've already got a lot of stuff in LibraryLink. Either we have all that stuff working in the compiler and an interface that provides all the capabilities of LibraryLink in the compiler framework, or we don't.
Right. The cost of adding a new data type to LibraryLink is more than the cost.
That's not the point. You're not addressing the point that I'm making. Are you saying that we should throw away LibraryLink and move all its functionality to the compiler, or are you saying something different?
I'm saying we should consider we shouldn't be putting more development.
No. I'm asking the question I just asked. What's the answer to that question? Are you suggesting?
Throw it away doesn't, it sounds like.
No, I don't care what it sounds like. You're basically saying all the functionality now available through LibraryLink is, quotes, easy, but although it hasn't been done, to make available through the compiler. Is that a true statement?
Yeah, that's a true statement.
Okay. What would be involved in making it available through the compiler?
We would write some Wolfram language code and compile it into something like LibraryLink.
Okay, so let's be specific. What would it look like? We would have a new library here, although we might. Well,
if we wanted to change the interface to LibraryLink, that would also make sense.
Okay, so wait a second. So we would have two things then. We would have a new interface, and we would also have bindings for the existing library that have a different implementation. Is that correct?
I think it would make sense to keep the old one active.
Well, it's necessary because we have a lot of programs that use LibraryLink. So what we would do is compile them against a new library, basically, to support the new approach, correct?
Here's what I'm saying, Stephen. If you want to build something like mprep for LibraryLink, it would be stupid to actually do that for LibraryLink. That would make more sense in the compiler.
Okay, I'm trying to be specific here.
Well, I was specific there.
No. I'm trying to be specific. What we're doing, what you are suggesting doing, is taking the functionality of LibraryLink, right, and using the compiler's mechanism for type declaration.
Well, it's not that. It's using the compiler's mechanism for working with expressions that's useful. That's what's useful.
Okay, so let's be specific. Okay.
Stephen, can I ask a question? So say I'm Piotr and I have, I don't know, 40 different LibraryLink packlets. Now, if you do whatever magic it is you think you can or should do in the compiler, what do I, as Piotr, have to do to my LibraryLink programs to make them work with your stuff?
Well, if you want them to work as written without change, then you do nothing.
That's not true. You have to recompile them against a new library.
No, I don't think so. So I'm just confused as to what Itai's asking.
The library link code, whatever code there is in library link, assume it's not in the distribution. What do you have to do? It's only compiler code that's in the distribution.
Well, it would be entirely feasible to have a compiler way of interfacing with the legacy, stupid union thing that we have. But wouldn't it be nice if you didn't have to?
No. I'm not interested in that. I want to know the answer to Itai's question. Right, we've got existing library link code.
Yeah, it could work.
Well, what does it could work mean?
Well, when I say
that code is
work,
sitting there.
I mean,
there are .so files that exist, or DLL files. I don't know what they're called in all these environments. There are DLL files that sit there. They're in some packlet. How are those DLL files being called? Right now, there is code that says library function load, is there not? That loads those library functions, right? Okay, that code, what happens to that code? Does it go away?
There'd be compiled code that does
No. I'm asking the question right now. In the packlet, we have the function library function load, right?
Yes.
Do we still have the function library function load, or do we have something different in the future in your model?
That's up to you, Stephen. If you want library function load, that could be implemented relatively simply.
Okay, all right, but it would be merely a wrapper around what?
It would be wrapper around some Wolfram language code that would be compiled.
What would the function be called that it is a wrapper around? Library function load is something which says there is an external program, it sits in this file, and now I want to load it so that it is callable from Wolfram language code. What is the analog of that for the compiler?
Well, I mean, it could be library function load. It could be whatever you want. I don't care.
No, but I'm trying to understand. In your model, there is a piece of external code that is that's a DLL.
It might be neater to have it with type annotations, like typed, rather than this sort of rather wacky integer type of thing. That might be better.
No. You've got the mechanism kernel function, which is a way of calling back into the kernel from compiled code, right? Okay, so the issue is you've got a random floating DLL out there, okay, different from what you have for compiled code, because compiled code is simply in the memory space, in Wolfram language memory space.
That's not true, Stephen. You can data structure isn't in the data structure is turned into a dynamic library and loaded into if you look at the compiler documentation for compiled function export library, that's exactly what it's doing.
Okay, fine. So what is the way that you load?
Data structure, Stephen, when you run data structure, you're not running the compiler, you're loading a library.
Okay, compiled function external library export. How do you run the result of compiled function library export?
Well, at the moment, you do library function load just on the library, and that extracts the function, and it generates a compiled
so you're using the stuff from library.
Here's an example. Look in the documentation.
For what?
Compiled function library, function compile export library. We designed this, you and I.
I remember.
Right. So you.
Okay, library function load. So you're using the very same function.
Yeah, it uses the same function as a convenience, and you just give it the library, and that generates a compiled code function.
Fine.
And look, you see, the interface that you give to it is like typed. It's a bit nicer than this sort of, bracket, and it's more, it's clearer because it says machine integer. It doesn't say integer.
Okay, Tom, wait for a second. Inside this dylib,
yes,
okay, the C code that Piotr would write, that is on that side of it, right?
Yes.
So something here, that is the declaration on the Wolfram language side of the interface to the internal code in here, correct? Inside function.dylib, just a second. Inside function.dylib, there is a function that has the body of that, arg+1, yes. Okay, so this is creating a library. Okay, this is doing the whole thing. Okay.
Yes.
So let's imagine that I was writing external C code, right? That will expose a single argument typed machine integer.
Right. So you could, one way of doing this, you would have some specification of the interface, and it might be nicer to use typed. And you would have
so that's
some other thing that references the library that you're wanting to suck in.
Okay, so that's extremely close to template files from 30 years ago.
Yes, yes, yes. I'm agreeing with you.
Okay, so let's be practical about what that could be. So imagine that so you have to expose that in the C code basically, and something has to harvest it and create an interface from it. Correct? You mean
in the kernel C code?
No. The C code that Piotr or whoever is writing for some random piece of functionality, right? Something has to tell it. It has to say in that C code, because that's a convenient place to put it, this is the interface that I wish to expose. Correct?
Well, he writes his library and it uses standard C ways. You declare something as extern, or if it's in a dynamic library, there's a few more declarations.
Wait a second. Okay, so what Christopher was doing was to read the C code and deduce from that what the interface should be.
Yeah, and he was reading header files. Yes, I believe, yeah.
Right. Okay, so one problem with that is the disowning of memory is not handled by that.
That problem is common to all of these things.
Okay, great. How do you plan on solving it?
But for this particular problem, that problem happens with template files. It happens with library link.
Well, it doesn't happen with template files.
The problem's obviously
important. It doesn't happen with template files.
But the problem
doesn't happen with template files. It does not happen with template files because they deal with creating. They are dealing with single function calls, right? And unless you use manual, if you give an array of integers, for example, there, it is responsible upon return from the function for.
Right. But in your template program, you might want data to live from one call to the next.
I'm aware of that. That's when you use the manual case of a template file.
Yes.
There is an automatic mechanism where it is a single call where the memory is allocated and deallocated when the function is called and when it returns.
But I think MathLink has disown functions as well.
Tom, you're missing the point. I'm saying, look, in the default case, memory is allocated. Okay, in the default case for WSTP, memory is allocated at the time when the function is called and deallocated when it returns.
I don't think that's true for everything.
Tom, I wrote this stuff 30 years ago. I know how it works.
Yes, and well, I will point out that was 30 years ago, and we've had at least 2 major interfaces since then. So
okay, I know that in the case of arrays, that's how it worked. When you could not pass the thing that was the whole idea of how the template file was architected, was to give people the expectation that memory will be managed.
GetString, WS GetString, Stephen.
I'm sure that it has a disown string piece of functionality.
It has a release WS release string in it. That's all I'm saying.
Yes. Okay.
So some of these things.
Let's go back. Let's go back.
Hold
on. Let's go back to what we were talking about. Okay. So your proposal is that Piotr's code, which right now is full of numeric array, get data, and things like this, right, would merely have its C data type declarations, right?
Well, he might want to know that he's getting a numeric array and he might want to create a numeric array and return it. So he might be calling the functions, similar functions to the ones that you see on the left-hand side.
I'm asking
mirror functions that are in the kernel.
I'm asking if all he is doing is getting data from the kernel, and what he could do is take his C data structures, okay, and automatically have those C data structures read and create an interface to them that would work here. So no declarations are ever needed except the ones in the C code.
Well, but Piotr might have top level
I
code.
don't care what he might have. I'm
Okay,
asking
fine. Well,
whether that case would work.
Which case?
The one I just described.
Describe it again.
Okay. You've got a piece of C code. It's got declarations in it.
Yes.
Okay. I don't know what happens with memory management, but let's assume it's stuff that's passed on the stack. Okay. And I hope Piotr is here and can respond to this.
I'm here. I'm listening.
Okay. All right. So you've got raw C code. It's got declarations in it. The whole point is you could, in principle, read those headers, read those declarations, and create the interface completely automatically. True or not true?
For stack variables, I think that's true, yes.
Okay, thank you. All right. First point. We're clear on that. Okay? All right. Now,
stack data.
Right. I'm sorry?
The data that's declared on the stack, yes.
Okay, so that's first point. Second point. For data that has to be explicitly allocated, we need a mechanism for dealing with that.
Correct.
That would be, I'm sorry?
Yeah, I'm agreeing with you.
Okay. In modern C++ and so on, which I don't know very well, how does that work? Do they have a mechanism for doing that, or are you still calling raw malloc?
No, you call something that's more abstracted, like new, a constructor.
Okay.
But basically, you still have the same issue.
Okay. But so you explicitly call that. So there's a pointer that you might pass on the stack, but then the actual memory allocation is happening through some constructor.
Yeah, yes, essentially, yes. The same. C++ doesn't add much, it adds more stuff, but no new concepts.
Okay, so in that case, presumably there is a declaration of what that new constructor returns, correct?
Yes.
Okay, so there is a data structure declaration somewhere there, which could in principle be read to create something which is an exposable data structure representation.
Right, now are you asking specifically about C++?
Well, yes. Or,
right.
I mean,
so now you're rapidly getting into very hairy, complicated things, way beyond what Christopher was looking at. You might have templates, you might have classes, you might have mixtures of templates and classes. You're in hairy territory.
And you have lots of other things, Stephen, like private and public data too.
Yeah.
And
right. Okay, so what is your proposal, guys? Right now, we have a working solution with LibraryLink, except that it's grown over the years. It's kind of a mess. Things are not very compatible. That guide page is an embarrassment, etc. Right? But we've got that model. Now, what are you proposing as, what's the modernization of that?
Well, the modernization of that would be to have generate code, top-level functions that take expressions that denature them into the calls into your C code and compile that.
Wait, but I don't understand that. I mean, I have some external library I want to write. I want to utilize. I don't understand what workflow you are proposing for me.
Well, it depends at what level you mean. Do you mean developing the code, using it, what?
No, we've got an existing piece of code, and we want to write glue code that will connect it to, that allows it to be callable from inside our language.
Yeah, fine. And what is your code? Is it taking like integers and?
No, it's taking, it has complicated data structures that it has to pass back.
With LibraryLink, you're utterly out of luck. None of these proposals for LibraryLink have anything to offer you whatsoever.
What? Hold on.
Wait. Listen. Quiet, Itai. All these extensions to LibraryLink are purely designed to take kernel data structures and expose them out. Not going in the other way around. You've got to understand that.
Well, wait a minute.
Sorry.
Right now,
yes.
Piotr has taken many libraries, many external libraries, and interfaced them to our language, correct?
Correct.
Very likely, yes.
Yes, and I'm changing the native C data structures into our M numeric array or M tensor, I have to do that. That's the big piece of the C code that we're writing.
Okay, so what does that look like roughly when you do that? Then you're writing an interface which takes those data structures, and then you're essentially explaining how to turn that into the native C data structures of whatever library you're using. Is that correct?
Well, right.
If I may, I think a better way to say it is he's writing functions which take data from the kernel and then call the functions from the library, and then take those results and return them to the kernel. Is that a fair assessment, Piotr?
Well, right. That's one scenario, that you want to transfer the data structure that you have in the kernel to the C code and possibly maybe store it in a file in a specific format.
Okay, so one thing that would be helpful to you perhaps is if the specification of the Wolfram language side data structures was made using, or actually either side's data structures was made using modern compiler typed this, that, and the other stuff, rather than this kind of nest of raw function calls that you probably are using right now in LibraryLink. You know what? I have to go. I'm really late for something else. Let's please.
Well, I just want to, maybe last thing I want to point out that we are using a lot of C++ libraries. And obviously we have to convert at some point the C++ data structure classes into what we have here. That is our M numeric array or M tensor or M image. But as Tom already said, it's not easy to take the C++ DLL and use compiler for that. The demangler issue and all of this, we know it's not easy. So it's okay for C libraries, not for C++.
Can we get a separate meeting specifically about this whole topic of calling external programs? And hopefully you guys can prepare some proposal for how this could be designed. Okay, and let's take it from there.
And in addition to people here, we should definitely have Rob in that.
And Todd. Okay. All right, let's see. Brian is mentioning C#. Yes. Well, C#, we have a whole separate, the whole .NET framework, we have a whole separate mechanism for dealing with. Yeah, I mean, this is a jungle. Realistically, this is, the whole point is that we have, over the last 30-something years, built this, we hope, shiny, wonderful, thing, but there's a jungle outside, and my analogy is falling apart. Yeah, it's complicated interfacing with all these different things. But okay, let's meet and talk about this again. And I'm really embarrassed by that LibraryLink guide page. And part of our plan needs to be what we're going to do to fix that, and to actually document some of these functions and put them on the guide page. All right, thanks guys. Thanks to people on the live stream. We'll actually be back in about 40 minutes for another live stream meeting. Talk to you all soon. See ya.
Bye.